Okay, let's evaluate the triple integral over q of x, y, z dv, where q lies between the sphere rho equals 2 and the sphere rho equals 4, and above the cone given by phi equals pi thirds. These are all in spherical coordinates. Okay, I've drawn what's going on here not in 3D, but as cross sections. So you can see the z-axis here, and if you can take the cross-section of the two spheres and the cone, you'll get something that looks like this. The outer circle represents the larger sphere of radius 4. The inner circle represents the smaller sphere, the cross-section of the smaller sphere of radius 2. And the two lines in red represent part of the cross-section of the cone. So then the question becomes, okay, how do we set up the integral? Well, okay, first of all, let's handle the integrand, because that's going to be a little bit long. X, Y, Z, we're going to integrate, hopefully it's clear, in spherical coordinates. So I'm going to need a lot of space here. Okay, X in spherical coordinates is rho sine phi, that's R in cylindrical coordinates, times cosine theta. So it really is R cosine theta if you were in cylindrical coordinates, and that's how you can remember it. So that's x right there, that's x, and then y is rho sine phi sine theta, which is kind of like saying, or exactly like saying, r sine theta. And then z turns out to be rho cosine phi. And then of course you need rho squared sine phi d rho, d phi, d theta. Now, the limits of integration. The limits of integration, well, hopefully it's clear that rho is going to go from 2 to 4. Is that easy to see? Oh, I think so. Look, the radius of this sphere, it's a cross-section of a sphere, is 2. The radius of the larger one is 4, so rho is going to range from 2 to 4. So there's your inner limits of integration. On the rho, on phi, well, okay, if you think about it, phi is the angle formed between the edge of the cone, represented by the red line segment here, and the positive z-axis. So this angle here is pi thirds. So phi is going to range between 0, which is basically the positive z-axis, and the largest angle you can get, which is formed by the side of the cone, and that's pi thirds. So phi ranges from 0 to pi thirds. And then, whoops. Okay, and then theta, to sweep out q, theta is going to have to rotate from, well, all the way around, from 0 to 2 pi. So I haven't really drawn q. I didn't want to try to do that, but basically, Q is going to be formed if you fill in this region and rotate it in space around the z-axis, you'll get the region Q that we're integrating over. Okay. So how does this integral simplify? Whoops. The limits of integration don't change. Okay, well, count up the number of rows. I think we have 5 rows. 1, 2, 3, 4, 5. So rho to the 5th. And then sine phi, I think we have 1, 2, 3, and that's it. So, okay. Thought we had 4. Let's see, we have 1 to go with the x, 1 to go with the y, and then just the one right there. So, okay, sine cubed phi. And then what about, let's go with cosine phi. There's one of those. Group those functions of phi together. And then functions of theta, there's a cosine theta and a sine theta. So that gives me, I'm going to write it like this, sine theta, cosine theta. D rho, d phi, d theta. Like that. And then I can write this triple integral as a product because the limits of integration are all constant, and I can separate the functions of rho, phi, and theta. So I could write this as, okay, the first integral would be the integral from 0 to 2 pi of what? Well, that's going to be the theta integral. So we have sine theta, cosine theta, d theta, like that. And then the integral from 0 to pi thirds, that's going to be the one with functions of phi. So sine cubed phi, cosine phi, d phi. And then times, see if I can fit it in here, times the integral from 2 to 4 of rho to the 5th d rho. Okay. Well, let me integrate this first guy, and it's actually not too bad, because if you let u equal the sine of theta, then du is already there for you. So without actually making the substitution, then this is like integrating u squared du, so that would be u squared over 2, or sine squared theta over 2, evaluated from 0 to 2 pi. Now here's the thing, I can stop right here. Look, the sine of 2 pi is 0, the sine of 0 is 0, this thing is 0. So 0 times the other integrals is 0. So I'm finished. The value of the integral has to be 0, because it doesn't matter what these other two values are. When you multiply whatever these values are times the value of this integral, which is 0, you get 0. So that's it.